Hello, everybody. Welcome to Chapter 8, Part 1. So we're going to start Chapter 8 talking about bivariate correlation. This entire chapter is based on the idea of bivariate correlation. So let's just make sure we're totally clear here. When we're talking about bivariate correlation, bi like a bicycle, bi means two. Bivariate, two variables. And specifically, we're going to be talking about correlation. That means correlational designs. We're talking about correlational designs of studies. So bivariate, two variables, correlational designs. Let's start with a review question. So let's start with this one. I think that sleep makes you happier. Okay, sleep, happier. I measure how many hours of sleep you had. Then I measure measure your happiness using a Likert scale. What is that? What is this example showing you? Is it A, two continuous variables, B, two categorical variables, C, one categorical and one continuous, or D, more than one categorical and one continuous? So, sleep makes you happier. If I measure how many hours of sleep you had, hours of sleep is ratio data, right? The difference between 1 hour and 2 hours is the same as the difference between 2 hours and 3 hours, right? They're all 60 minutes, and 0 means 0 hours, 0 amounts of time. That's ratio. Ratio is a form of a continuous variable. Then I measure your happiness using a Likert scale. Well, Likert scales are ordinal. Likert gives us ordinal data. So Likert response format gives us ordinal data. Ordinal, interval, and ratio, they're all continuous. So sleep is a continuous variable and happiness is a continuous variable. That's two continuous variables. Okay, so with this, we need to talk about statistics because sometimes you got to talk about statistics. And this is one of those times. Statistics is like a pregnancy test. Remember when we talked about type 1 and type 2 error? Okay, so I'm sorry if this is uncomfortable for anybody, but what's really going on is kind of like a woman trying to understand whether she's pregnant. Okay, she doesn't know for sure, but the test, the statistic, is going to tell us what is probably happening. Now, more specifically, the statistic tells us the probability of getting a specific statistic if the null hypothesis is true. And so what's really going on with a statistic is like a pregnancy test that always tells you that you're pregnant. A statistic is like a pregnancy test that always tells you you're pregnant. What I'm saying is a statistic always says that something's going on. As long as the value of the statistic, let's say it's a Pearson's R or a t-test, as long as the value of that is not zero, absolutely zero, then it's saying there's a relationship between the variables. Well, so what you care about is not necessarily what the test tells you, more so than whether or not you should trust the test. What is the probability of you getting this if the null hypothesis is true? So in pregnancy, the null hypothesis would be that you're not pregnant, right? Nothing's happening, no pregnancy. And so what is the probability of you getting a positive pregnancy test result when you're not pregnant? When we talk about p-values in statistics, it's like a pregnancy test, but the p-value is the probability that you're going to get a positive pregnancy test when you're not pregnant. Okay? That's what the p-value is. The statistical test, whether it's a Pearson's R or a t-test or whatever, that's like the pregnancy test, and it basically always tells you you're pregnant. The p-value is whether or not you should trust it. All right. So when we're talking about bivariate correlation, we're going to talk about two different tests, two different statistical tests that you would use. And the reason why it's so important to know whether or not you have categorical or continuous data is exactly for this reason. You cannot use a Pearson's R when you should be using a t-test. And you can't use a t-test when you should be doing a Pearson's R. Technically, there are ways you could, but that's not the point. All right, so with a Pearson's R, we use a Pearson's R when we're talking about two continuous variables. All right, so remember, this entire chapter is bivariate correlation. And what we're talking about with that is not Pearson's R correlation, we're talking about like a correlational study. That's what we're discussing, all right? It's like a correlational study. We often call a Pearson's R a correlation because it's a, it's a statistic that tells us correlation. It's Pearson's product moment correlation coefficient. That's its official name. But what we're really talking about when we're talking about bivariate correlation is there's two variables, and those two variables are in a correlational design. So let's go ahead and try and show you what this looks like with our circles and squares. So here we got a circle, and a square, and a square. These are ugly squares, right? So let's say that because we know we're doing a correlational design, what are we going to do? Are we going to, what are those operationalizations going to look like? In a correlational design, you measure and measure. That means we measure this variable and we measure this variable. And then, because we're measuring both, we don't know which way, which one's causing which. It goes both ways. So let's say that in this particular case, we're looking at the effects of studying. So that says study. That's really bad. That says studying on your grade. In fact, your grade, let's let the grade be your GPA. All right. To make that clear, let's just kind of erase that. Let's let the GPA be the operationalization. So this is your grade. Okay. The idea here is if you study, it's going to affect your grade. That's the idea. But because we're only measuring how much you study and measure your grades, we don't know if the grades cause you to study more, or if the studying causes you to get better grades. We don't know. We don't know because it's a correlational design. Let's say we study your grades as your semester GPA. All right, that's going to be your operationalization of grades. Now, how we measure the studying is going to be important. So first of all, when you look at GPA, GPA is continuous. We know that a 3.0 GPA is more than a 2.0, right? We know it's more, and we know that the intervals are roughly the same, okay? But in this case, 0 doesn't mean 0 ability, 0 knowledge. It does kind of mean 0 grade, I suppose, but it's at least ordinal. It's at least interval as well. So we know that this is continuous data. So GPA is continuous. I'm going to write that up here. GPA is continuous. Okay, now studying, there's several different ways that we can measure studying. So one way that we can measure study is in hours. I just ask people, how many hours did you study per week? And then I look at your GPA at the end of the semester. So that's one way that we can do it. So this is hours. All right. Hours gives us what kind of data? That's right. Hours gives us continuous data. Specifically, hours is ratio, right? The number of hours that you study is ratio data, and that's continuous. So hours is also continuous. Okay? That means that if we measure how many hours you studied and we measure your GPA, what we're going to do is we're going to use a Pearson's R as the correct statistic to test the relationship between those two variables, because GPA is continuous and hours is continuous. And we see whether or not they go up or down, with a positive correlation or negative correlation. A t-test cannot do this. A t-test cannot test this, at least with these operationalizations. Instead, we could do the same hypothesis that studying and grades go together, but when we're looking at this, let's go ahead and erase hours. Instead of studying being measured with grade, we can just ask, did you study? Yes or no. Okay? Yes or no. That changes the data from continuous to categorical. You're either in two groups, the yes study group or the no study group. That's what you're in, right? And you have one group that studied, one group that didn't study. And then you see what their GPA is going to be. When you do this, you have one categorical variable, studying, and one continuous variable, your GPA. Okay? You have to do it. Well, you can't use a Pearson's R for that. You use a t-test. Now, a t-test is specifically for categorical variables, one categorical variable that has two levels. In this case, we have a categorical variable. Did you study, yes or no? And there's only two variables, or two levels, I'm sorry, two levels. There's only two levels of that, yes and no. Okay, those are the only categories. A level is a category, and when there's only two categories, then you can use a t-test. So a t-test is one categorical variable, studying, that has two levels, yes or no, against a continuous variable. All right? So when we are looking at a bivariate correlation, the two variables, studying and grades, it depends on what kind of data we're going to get from the operationalizations. Let's go ahead and look at the p-value, the idea of p-value. When I run that statistic, whether it's going to be the Pearson R or the t-test, I'm going to get a p-value. The p-value is the probability of getting that number if the null hypothesis is true. It's kind of like, what would the probability of getting by chance? It's kind of like, what is the probability of getting a positive pregnancy test when you're not pregnant? That's what a p-value is. That is different from the effect size, which is how big is the effect. All right. So the difference between this is like this. So let's say that we have the theory, the hypothesis that studying more is associated with higher grades, a higher GPA in this particular case. Okay. Now we run. Let's do the Pearson's R, right? We measure how many hours you study. We measure your GPA. Let's say that we get a they say that we get an R value. R is the statistic. Remember Pearson's R. R equals 0.73. That is the statistic. It is not the probability of getting a 0.73 when there's no relationship between the two variables. A p-value is the probability of getting that number, R equals 0.73, when there is no relationship between studying and your GPA. That's what a p-value is for. How big the effect is means how much does studying affect your grades. That's the effect size. How big is the effect? The p-value just says whether or not you could have gotten that value by chance, but the effect size says how big is the effect. So, quick quiz. Which of these does not measure bivariate correlation? Cronbach's alpha does not measure bivariate correlation. Cronbach's alpha measures internal reliability, which is not the same. It's not the same. It's not what it is. In fact, Cronbach's alpha can have lots of different items in it. That's not what its purpose is. You can do a t-test, you can do an R. Either one of those will give a bivariate correlation depending on what kind of data you get from your operationalization. So let's look at this one. I think that there's an association between what school you attend and how many alcoholic beverages you consume. I want to compare CU Boulder, Colorado State, and the Colorado School of Mines. So I think that there's a difference in how much drinking happens between those three schools. And so I get a bunch of different Colorado university students in Colorado, some from each of those schools, and I measure how many drinks they consume within a week. What test am I going to use for this study? The answer is none of the above. The reason why is because when you're looking at this, first of all, let's figure out what kind of data we got. All right, so number one, what school you attend. You can attend either CU Boulder, Colorado State, or the Colorado School of Mines. So those are categories. They're not continuous, because that's nominal data, right? You're either at CU Boulder, you're at Colorado State, or the School of Mines. Those are categories. So that's a categorical variable. And how many alcoholic beverages you consume, that's a number, right? So 0 means 0, and the difference between each is more or less, right? So we know that that's continuous. We know that that's continuous. So automatically we know we cannot use a Pearson's R. We can't use a Pearson's R because that's for continuous with continuous. We have categorical with continuous. Well, look at this. A t-test, doesn't that cover categorical with continuous? The problem is that a t-test can only handle 2 levels of the categorical variable. A t-test can only be done with 2 levels of a categorical variable. We have 3 levels of this categorical variable. They are CU Boulder, that's 1 level. Colorado State, that's another level. Colorado School of Mines, that's a 3rd level. 3 levels of that continuous variable. So in this case, you cannot use a t-test. Effect size is just how big the effect is of your school on how much drinking happens. So the answer here is none of the above. For those of you who remember stats, the real answer would be a one-way analysis of variance. But of these options, you can't do it. So it's none of the above. All right, let's take a look at some example data. Let's do an example data, remind ourselves how to do these and what it would look like. So I did an activity with a previous semester where I created an extroversion scale and a loneliness scale. So I had all my students take each of these. So they took an extroversion scale, a loneliness scale. They told me how many texts they sent yesterday, within the last 24 hours. Then their relationship status. Now the relationship status was either in a relationship or out of a relationship. I took all of that data and I linked it with their grades for my class, most specifically the exam 1 score. All right. So what we're going to do is, this is the first half, we're going to look at some examples of how we would do this. Then in the second half of this chapter, we're going to run some tests with the real data. So first of all, let's think about what we're going to get. In a scale, how many scores should I get in my extroversion scale? When I'm analyzing the data, how many scores am I going to get for my extroversion scale? For any scale, remember a scale is multiple self-report items that measure the same concept. For any scale, you are going to take those multiple self-report items and you're going to chunk them together. Either you're going to add them up or you're going to get an average and you're going to get 1 score. All scales give you 1 score. The vast majority of scales also give you continuous data. So as long as you're using something like a Likert response scale or a semantic differential, then you're going to get continuous data. In fact, it's kind of hard for you to get categorical data, even if you ask yes/no questions. But that's because you add them all up for 1 score, right? So you almost always get continuous data from a scale. What kind of data am I going to get from texts? Okay, text is ratio data, so that means it's continuous. The number of texts, 0 means 0, more means more. That's continuous. That's at least, or no, it's actually ratio data, and so is continuous data. Relationship status. What kind of data am I going to get from relationship status? So that's going to be categorical, absolutely. In fact, in this particular case, the 2 categories are you're in a relationship or you're out of a relationship. You're in or you're not, right? So how many levels do I have? 2 levels. I have 2 levels. Okay, what about your exam score? What kind of data am I going to get from your exam score? All right, exam score gives us continuous data. The exam score is going to give us continuous data. So here's what we're going to do. Let's go ahead and open up this data file. Okay, so we looked at, so what I've done is I've opened up some pretend data that I got from these. And this doesn't have the exam, but let's talk about what kind of test you would use for each one. And in the second half, we'll actually run the statistics. So, okay, remember you told me about what kind of data we're going to get from each one. Let's say that I wanted to know whether or not people who are in a relationship are more extroverted. So if that's my hypothesis, people who are in a relationship are more extroverted, what kind of test am I going to use? That would be a t-test, because this relationship status right here, you're either a 1 or a 2. So 1 is single, 2 is in a relationship, okay? And so this would be a categorical variable. The categories are single or in a relationship. I just have them represented as 1s or 2s. And then I would check whether or not people who are in a relationship are more extroverted. Okay? Second example. Let's say that I want to know whether or not people who are lonely send more texts. We would run a Pearson's R for that, because loneliness is continuous data and texts are a continuous data. That's exactly what we would do. Okay. Now, let's say that I want to know if loneliness and extroversion both predict how many texts you sent. What kind of test am I going to use? I cannot use either a t-test or a Pearson's R, because loneliness is one variable, extroversion is a second variable, and they're both of those, 1, 2 variables, are predicting a third variable, which is texts. Based off of bivariate correlations, I can't do that with any of the options that I gave you. I can't run a Pearson's R, I can't run a t-test. That is a separate test, which we're going to talk about in the next chapter. Okay. When we look at these kind of data, you should know that when you look at these data, here's what the output is going to look like in a graphical form. So this is a sideways bar chart looking at, in this case, it was extroversion based off of whether or not you are or not in a relationship. I think it was I can't remember. If it was extroversion, loneliness, I don't even remember what it is, right? But it's showing the more for one group versus another. Now, what kind of claim would this be based off of what we just talked about? I measured how your relationship status, I measured let's say this is loneliness. I measured loneliness. What kind of claim would that be? All right, that is an association claim. One variable, which is going to be your relationship status, is predicting the other variable, loneliness. Okay? A frequency claim would be something like 2/3 of my respondents were single. That would be a frequency claim. It is just telling you about one variable, and in that case it would be your relationship status. This cannot show causality because I measured your relationship status and I measured the loneliness. When I measure and measure, it's got to be a correlational study, and correlation does not equal causation. So here is the data that I got from extroversion and loneliness when I put those two together. I got R equals -0.21. Okay? Should I reject or fail to reject the null hypothesis based off of this statistic? The answer is I don't know yet, because we need to know the p-value for that. P-value is the probability of us getting this statistic, a -0.21, when there is no relationship between extroversion and loneliness. So this p-value right here is the probability of getting -0.21 when there really is no association between extroversion and loneliness. Okay, that is different than the effect size, which is how much does extroversion affect loneliness. That's what the effect size would say. P-value is not about effect size. All right, thanks everybody.